Hello everyone, welcome back to Year 9 Mathematics. My name is Victor and today we're going to cover volume of cylinders and prisms. Now in Year 8 we learned that the golden rule of volume for prisms, it is just the area of the front cross section stretched backwards. So you multiply it with the depth. Okay. In Year 9 the rule doesn't really change, the shapes just get more complex, that's all. Now volume is area stretched backwards. Volume equals area of cross section multiplied by height of depth. So it basically means that V equals whatever this should be here, this surface area, the cross section. This is going to be A multiplied by H. The depth here is going to be 10. So H is our H is 10. We just need to find A. We'll find V. Now let's look at prism. That is, the front shape is an L shape composite. Now it goes back 10 meters. Now first, you must ask yourself, like, is it a true prism? Like, if I slice this object repeatedly from front to back, will every slice look exactly like that L shape? In this answer is going to be looking yes. This means that it is a true prism, and we can find our golden, and we can actually use our golden rule right here. Okay, so we want to split awkward shapes into rectangles or any kind of well-known shapes, and we use our formula. Okay. So we need to find the area of the front cross section. We did this exact shape in Year 8 series on the composite area, and we're going to split it into two rectangles, as you can see right here, A and B. So the top rectangle is 6 by 3, so let's calculate first. 6 by 3 for B. I'm going to write for B here, B, 6 by 3. This is going to be 6 by 3, so this is going to be 18. The area is going to be 18 square meters. The bottom rectangle, right here, for A, this is going to be, now we know for sure this has to be 8, right? This is the entirety of the length itself. Of course, we need to calculate A. So if we're looking at this and we go, okay, if this is A, this is 8. Then we need to look 8. And then we need to calculate how much for the remaining is A. So we need to calculate that 8 should be multiplied by 6, I believe, or so. If this is 3, then the rest here will be 5, yes. But we did not draw this line right here, as you can see. So if we're actually calculating just originally this whole thing here, A, it would be 8 over 6, but this is actually visually a little bit glitched right now, as you can see. I actually intended this to be around 5 or 4 or so. A little bit, the math is going to be a little bit glitchy here, but I would still help you guys calculate this A out. So I need to find the area of the front. So this is B, this is going to be A. This math is wrong, of course. This A right here, this entire thing, because this is the this is going to be the length. So the A, I have 8 here. I need to find the width. The width here, it says 6, so I'm going to apply 6 here. You can't really deny that it is a 6. It says 6 here, and this also is a 6 as well. So this is going to be 48, of course. And so I need to find the area of the front cross section, as I just need to add A plus B. So this will be 18 plus 48. This will give me 64. So that is 64. Because I have the formula V equals area multiplied by H. The H is 10. So I'm gonna replace A here. Actually, this is gonna be S. S equals here. So S. This is S is 64. I just add all that up. Now I'm gonna multiply with the depth. The depth is gonna be 10 here. So I have 10. So I should have my answer as 640. Very sorry for the math right there. It looks a little bit visually glitched, but that is going to be our answer if we're going to calculate all of these together, A and B together, of course. So Again, we run our checklist. Is it a true prism? We will slice it from front to back. Every slice is a semicircle. Is it? Then yes, it's going to be a prism. Now, we need to go into our next example, which is going to be a half cylinder. I'll keep this, just keep this up, of course. Half cylinder here. Now, if we slice it from front to back, every slice is going to be a semicircle, okay? So the area of the front circle, I need to write the area first. So the area is going to be pi squared, pi r squared divided by 2. Because it's a semicircle, it's gonna be, so it's gonna has to be divided by 2. So the radius is 4 here, so it's gonna be pi 4 squared, and 2 here. This is gonna be 8 pi, because this is 16 divided by 2. This is gonna be 8 pi, like that. And then we found, since we find this, we will find that V equals area multiplied by depth. So what is the depth? 15 here. So I apply 8 pi multiplied by 15, and this should give me an answer of 120 pi in terms of centimeters cubed, because we're talking about volume right here. And in the upward here, I also forgot the unit as well. Like, even I, as a teacher, can make mistakes. So you guys do need to check your work at times. Yeah. So that is centimeters squared, no, cubed. This is also cubed because we're talking in terms of volume here as well. Okay. So then in a calculator, if you were to calculate this, this should look something like 376.99 cubic centimeters or so. Yeah. Okay. Please remember this formula. Of course, V, the volume, is area of cross section multiplied by that by depth. The shapes just get more complex and they may look glitchy at times, but again, remember what we have learned in year 8. You split them to remote known shapes, and you apply, and you consistently apply the formulas. The formulas is going to be just plug and play once you know all the variables. So find the 2D area first. Know that volume is just front area stretched backwards, because that's outer golden rule, and then add the 3D depth right there. Thanks for watching. I'll see you next time.